Okay, here's an Alex question that's dealing with some valence bond theory that we've talked about. I think that these problems are fairly basic, and we can do those. It asks about the highlighted atom here. This is going to be the oxygen in this case, and it's asking about how many sigma bonds does the highlighted atom participate in. And so look at that oxygen, we see that single bond, that sigma bond right here, and we see that sigma bond that's going from the oxygen to the hydrogen. And so in this case there is going to be 2 sigma bonds. Now, do we see any pi bonding that's going along? Any double bonds that we see associated with that oxygen? We do not see any, and so in this case there are going to be no pi bonds that we have to worry about. And then it's asking us, what is the orbital hybridization of the highlighted atom? Well, we see we have 4 electron groups around there. That indicates to us that there needs to be 4 hybridization orbitals. And when we form 4 hybridization orbitals, then that is going to be what we call the sp3 hybridization. So that is the hybridization that's going on around that oxygen. And so let's go ahead and check this, and it should tell us that we're right, and it does tell us that we're right. Okay, let's go on to some others here. Let's check out this next one. It's asking about this carbon, okay? And so we see that the carbon has a couple of single bonds attached to it, but it does have a double bond attached to that oxygen. This is going to have some pi binding associated with that, some pi bonds. And so how many sigma bonds does the highlighted atom participate in? Well, there we see a single bond going from that carbon to that other carbon, and we see a single bond from the carbon to the hydrogen. So that is a sigma bond, and it's important to realize from our lecture that as part of this double bond there is sigma bonding that goes on right here. And so we see that there is 1, 2, 3. There are 3 sigma bonds that are associated with this particular carbon. How many pi bonds? Well, we see that there are going to be no pi bonds in these single bonds surrounding carbon, but we do have, in a double bond, we do have 1 pi bond that the atom participates in. And so in this case there's going to be 1 pi bond. And so what type of orbital hybridization is this going to be? Well, if you remember from our lecture, we are forming those 3 bonds right here that we see. There's 3 sigma bonds plus that pi bond, and this happens to be sp2 hybridization. And so let's go ahead and check that and make sure that we're right in this case, and we are right. But I want to look at this explanation just real quick, because I think there's some cool things that it shows here in the explanation. Okay, so it gives us these, it's kind of showing us how these sigma bonds and pi bonds are formed, and it asks us to drag a slider right here. So we have 2 p orbitals that are going to hybridize here and form a bond. And so we see that as those bonds get close, we form that sigma bond. Okay, this is that sigma bond that is forming from 2 p orbitals. Now, how is the pi bond formed? Well, if we have a different orientation of the p orbitals, then we can see that that pi bond forms by this overlapping that occurs. Okay, so this is how the pi bond forms, and I think it's just a good visual to show us this type of hybridization that can occur. And let's just answer quickly just a few more of these right here. Okay, it's asking us about this carbon right here. We see that we have 1, 2, 3, 4 sigma bonds surrounding that carbon. So I'm going to put 4. There are no pi bonds, and when I form those 4 hybrid orbitals, that's going to be sp3 hybridization. We'll go ahead and check that, and we'll be right. Let's go on and see if we can find one that has a triple bond right here. We already did a problem similar to that, so let's skip that one and see. Hopefully Alex will come up with a triple bond for us. It doesn't right there for the highlighted atom, and it does right here, so this will be good for us to look at. Okay, so we have this carbon that is going to be right here. We see that it's actually, there are two bonding areas right here. We go from this carbon to the left-handed carbon right here. That is a pi bond, and we see that pi bond, or excuse me, sigma bond. But we should know that between this carbon, even though that's a triple bond, what forms that triple bond is also a sigma bond as well. So there's a sigma bond going off to the left carbon and a one sigma bond that is part of that triple bond. So I have two sigma bonds. Now how many pi bonds? In this case, I'm going to have two pi bonds. I've got the one sigma bond that helps form that triple bond, but then I have two of those overlapping pi bonds that are going to be there. So that's going to be two, and the type of orbital hybridization that's going to occur here is sp. And so let's go ahead and let's check that and make sure that we're right. And we are right. So these are doable, just understanding what is a sigma bond, that single bond there, and then what goes into a pi bond, or multiple pi bonds in this case.